that was me getting another backer.
Yay!
So, as you've all heard, we've got a Kickstarter going. It is for a universal LED driver. Basically, we've been dealing with all sorts of LED strips for a long time and wanted something that would abstract away all the annoying bits. So it's called the All-Pixel, and it's based on the 18NEGA32U4, and it can drive 8 different LED strip types, 3 of which are the major ones that you generally hear, which is the NeoPixel, the WS2812, WS2801s, and the LPD8806. This is a display that Dan made for just a demo. That's the W2801, or WS2801, sort of the Christmas tree style lights. I was just going to show you kind of a quick demo. We've also got an entire library that I've named BiblioPixel, which drives this, but also will drive these lights directly from a Raspberry Pi without it, should you really want to. Like pretty much anything that's SPI, it'll drive those. It won't do the NeoPixels, which is actually part of the reason why we designed the board in the first place, to get around. I mean, technically, yes, you can drive it from a Raspberry Pi with some kernel kung fu, but I don't like doing that.
It's dangerous.
Yeah, so BiblioPixel is pretty easy. It'll handle matrices and
Now, in my defense, I did have a demo ready to go, but
I wanted to show you how easy it was.
Yes.
It'll take me like 2 seconds.
We have a clock running right now, so 9:15.
2 seconds.
Yep.
No, but it is. I mean, it's the software library takes a lot of the complicated setup and communication timing aspects out of getting your software up and running. Adam can explain it better, but it's a couple of lines instead of having to activate your SPI interface, set it up, get the timing right. It abstracts a bunch of that away while still giving you the flexibility to write some pretty impressive animations. Once you figure out the basics of how the library is set up, then it's a matter of usually just some basic math or complicated math, if you so desire, to make pretty lights and pretty designs show up on your strips.
Yeah, should you want to, you can do the complicated math.
Sure. Some people enjoy that.
Yep.
I personally don't, but
So
I respect.
BiblioPixel works with a driver model, which allows you to pretty much just write your animations once and then fill in the driver to output to whatever you want to later on. So I'm using driver serial, which is for the All-Pixel specifically. It's a USB CDC serial communication. It has full 12 megabit per second throughput. And so instantiated the driver, instantiated the LED class, which handles all the matrices and whatnot. And then, let's see, we'll pull in some animations for boom. Here's the LED. This will create a nice little flower, sort of rainbow blooming animation. What?
I haven't tested, or I haven't run it on this one to see what it looks like, but I tried to do the scrolling text, and since it's only 5 pixels high and the font is 8 pixels high, you kind of got it cut off. But like Adam said, this was just for demo purposes. I mean, you could take this and make it the size of this wall. Probably be a lot.
So there's that. So did you power it up on?
Yeah.
Yeah, okay. So watch, I'm gonna like make a fool of myself. So what it's doing right now is it's saying, oh, I don't know about, what did I do? Import. I didn't import enough things.
Import all the things.
When you change the type of script that you're using, it automatically reconfigures itself, reboots, and comes back so that it has the right size buffer and the right drivers loaded. So then we can do something like this. Some of you probably saw the similar on my other display at the Maker Faire. And that's really all that you ever need to do. I mean, like Dan said, you can get into some pretty complex math I've done Game of Life, I've done Simplex Noise, you know, all sorts of things. I actually have this, I mean, this isn't dense enough, but I can run full graphic animations loaded in a GIF file and it'll run the whole thing. And
the library ships with a couple of basic animations, as Adam's demonstrating here, just to get you started, to get you up and running, to make sure that everything's connected properly. There is also there's a test pattern for if you have it in just a long strip configuration, or if you have it in this configuration. That will indicate to you make sure that your color channels are right, that if your strip is configured for BRG, you can find that out and configure it in the software so that all your colors show up correctly. If you have it in the matrix configuration, you can make sure that it's oriented properly. If you need to rotate it or flip it, depending on how you have it physically installed, there's some configurations you can do so that you don't have to build it a certain way. You can throw it together and in the software change it based on how you have it set up.
so, as he was saying, and I know for a fact, this is not configured in the right orientation.
Right.
It should be coming from this side, but this is basically just to show you, okay, yes, we've got red, green, and blue, and normally it would be going vertical lines. I didn't configure this for that, but I could. I'm not going to go through all that. There's ways of rotating it, flipping it around, doing any of those transforms that you need to do.
Can you give us some basic information? Are you be able to control the color and intensity of an individual LED?
Yes. Every LED is completely controllable. I can change the brightness across the entire strand. There's a method just called Set Master Brightness, so you can do the whole thing. But you can also do scaling on any individual pixel if you want. There's a full segment of color classes that allow you to do HSV color, both with the standard sort of 0 to 359 or 360 setup, but also a modified one, which is a byte-based HSV, which is about 6 times faster. It's not quite true to the normal HSV color space, but I've rewritten the entire thing for speed. So a lot of times it's close enough for what you need, but you can do it either way.
So I'm new to this world of things. If I may ask, how much does a strip like that cost? And you said that was SPI fund? So you're doing SPI communication to drive those LEDs?
Well, we're doing serial to the all pixel, and then the all pixel is figuring the rest out. It is SPI in this case.
The lights themselves are an SPI communication. These right here, I think, off of eBay were.
I want to say it was like
I think
$30 for 50.
Yeah,
Maybe
I think I
60
paid
total.
about 70 for all of this with shipping and all that kind of stuff. And granted, that's on the slow boat from China, but they do work, and they. I mean, I would. Once I'm done with this, I'm probably going to take them off of this and put them on my Christmas tree.
Which flavor are those?
These are the WS2801 style chipset. So if you were to configure it in here, or if you were to just use the software library somewhere else, you would want to make sure you're using that correct protocol for it.
Is that,
Yeah.
that SPI, the 2801 is the SPI?
It's standard SPI, limited to 1 megahertz. That's sort of the one of the downsides. So like on the Kickstarter, we're actually making it available so that you can buy with the kit a 5-meter roll of LEDs. You can choose between the WS2812, the WS2801, and the LPD806. The major difference between the last two, despite both being SPI, is that the LPD806 is 2 LEDs per chip, so you can only divide it every 2. And it's also only 21 bit color as opposed to 24, which is what these are. So these will give you a little bit better color depth. However, these are 1 megahertz. The LPDs are up to 30. So like I've used LPDs for persistence division stuff and just much higher frame rate things.
So
I mean, you're addressing each LED each LED then has an address, which is part of the packet.
It's a
you set up a buffer of bytes, isn't it?
yeah. It's a shift register. Is really all any of them are. You shift enough. So with these, since it's 1 chip per LED, you shift in 3 bytes. The next time you ship another 3 in, it shifts those to the next one.
Oh.
and then just
Well,
goes
you
down
got-
the line. So honestly, I could hook this up and tell it, you've got 1,000 LEDs, well, 680, because that's what we support. And it would just happily do it, but all you would see is what was at the beginning of the strip, not the other stuff.
Or you could take this entire thing and tell it only has 5 LEDs, and it would just.
All the extra electrons would just kind of fall out at the end here, and
Exactly.
we'd be done with it.
Wasteful.
You need a bucket?
Yeah.
Yeah, I
Might
never
might
keep a
need
bucket around to
towel
catch them.
to mop up the extra electrons. So just a quick word on powering the LEDs.
Can I ask a question about the shifting before you go to power? That's awesome, but how does it say light? I mean, you say you shift it in, but as that data shifts down the register, it seems like each one, because you have blank ones there in the chain. Is there?
Well, because what it's doing is like, so for this one, this blank right now, what it did was it sent it 0, 0, 0. And it just didn't care beyond that.
Okay, but so presumably there's a way you shift the data into the whole string and then say, turn on now. And then you shift a new set of data in and you say, okay, now you've got your new data.
Yes, okay. So that's actually one of the major reasons why we built the board, because they all had different protocols. So with the WS2801s, you shift all the data in, pause for 50 microseconds, and then it knows, okay, latch, send them off. With the LPD8806, you can send them in willy-nilly as much as you want, and the reason they're 21-bit is because the 8th bit is reserved as a latch bit. So when you send in a full, or when you send in a byte that has the 8th bit set, then it latches. The WS2812 or the NeoPixels are even weirder because they've got this weird nanosecond timing that, since it's one pin, it's looking for a very specific 800 kilohertz data signal, and then when it gets a particular delay of a certain size, it stops. I don't know the details. That's why I made that.
But that does.
That knows all the details.
Right.
It's actually, the firmware is based off of a library called FastLED, which without that, this might not have been possible, or at least I would have pulled a lot more of my hair out. You just kind of say, oh, it's WS2812, and okay, I know what that is, I know what the protocol is. Most of its protocols under the hood are written in assembly, they're stupid fast. Even I didn't try to look into it. I was like, I don't care. It just works.
Black
So
magic.
it's done.
It's black magic.
But yeah, so like with it, I don't want to take up more time, but like, for example, I've got LPDs, an LPD strip over there. I could hook that up to this right now, change this to LPD, run it again, the board reconfigure, and it works. Same animation, no fuss.
Nice.
So one of the other things that we have with the Kickstarter is we're calling it the Power Tap, which is do you have a picture of that?
Oh, yeah, I can pull up a
It's
picture.
a really small PCB that all it does is allow you.
Well, that's unassembled. We don't have an assembled picture.
That's fine.
Okay.
It's just an easy way to connect multiple strips together. So you have a screw terminal on the input, screw terminal on the output, a barrel jack, and a giant capacitor for smoothing out your power over longer runs. You may or may not need to use that, but we found that for certain strips that helps, especially when you have long runs and you're only splicing in power every so often.
And it's basically, there is a 5-volt pin here, but that's not connected to anything. It's only connected here on the output. So you have ground that carries through. So you maintain a common ground, and then it just splices 5-volt power or 12-volt if you need it into
So
the
you
rest
don't
of it.
have two different power supplies potentially conflicting with each other, providing slightly different levels of 5 volts. So.
Which is how I've wired up pretty much all my stuff.
What
So
is the
just as a
current
sort of
limit on the
formalizer.
barrel connector?
The barrel jack is off of the All-Pixel itself. 5 amps is what we have listed as the spec for it. It will do, I think, up to 8 safely, but
We
in the
just
interest of
told people
being
5
safe,
to cover
5
up.
amps is a nice round number.
Why?
Yeah, and similar for the power tap. about 5
Yeah,
amps.
so if they put in a really exceptionally, unbelievably bad solder joint, it won't
They're not totally
overheat.
screwed.
Yeah, right.
And as we found with these, I mean, I've played with enough of these LED strips that, like, for example, a 5-meter roll of the LPD at 30 pixels per meter will claim that it's going to draw 12 amps.
If you look at the math,
I mean, if you look at the math as like 60 milliamps per pixel or 20 milliamps per color
at full light,
at full
Right,
light,
full white, full intensity.
it will, but it never does. So
It's, I mean,
And also like with this, I mean, it's only ever kind of half on.
so this right here is, based on my testing, is probably pulling between 800 milliamps to an amp of power for 100 of these decent brightness, nice rainbow animation going. If you were to send all of these to maximum brightness, full white, what you would actually see is towards the middle, because of the current draw, your voltage would drop a little bit, and they would actually turn pink because of the loss of voltage. So what you would do is, if you really wanted to get that to work, you would splice in another power tap right here to provide provide more power to the rest of the screen.
Yeah, so like you see on this one, we've actually got power at both ends, just running from either side. And I mean, you can do it sort of either
That's all
way in the
dependent on
middle.
how dense your LEDs are, how bright you have them running, what animation you're running. Obviously, certain animations will draw more power based on the color that you're showing. So.
And actually, it's something of note with that. We've provided a bunch of optional components basically because we don't necessarily know how everyone's going to want to hook it up. There's a lot of options. There's the barrel jack for doing power like we've got here. The diode at the top there is actually, you can place it in that spot on the left of the barrel jack, which allows you to power everything off of USB. Obviously, you're limited to about half an amp. We do actually have a half amp polyfuse on there just to be extra sure. And the diode's there so that you don't then later plug in 12 volts to the barrel jack and fry your nice expensive computer. Again, we've got the capacitor for smoothing. We've got a couple of optional resistors, which there's jumper pads on those, which that's the places right to the left of the C5 capacitor there. Things like the NeoPixels often are a little bit better if they've got a resistor in there just to lower the logic level voltage. Protects them a little better. I've fried far too many without it. And then the screw terminal again, as well as we're providing a standard 4-pin header for connecting to a breadboard.
What was the processor again?
It's a ATmega 32U4.
I'm sorry, it's slow.
32U4.
You are using a 32U4?
Yes.
And you were able to get the USB bus and all that to work well?
Yes. That's the other interesting detail. I rebuilt a completely modified version of the Teensy 2.0 Arduino core specifically for this.
Really?
Yes.
Get the
So
maximum USB
the standard throughput on like the Leonardo core libraries, or what they would use for the Pro Micro or any of the other
This is
standard,
the bootloader.
not the bootloader, but the core USB stack
Okay.
is really slow. You're limited even on, and before this we tried FTDI, which was, forget it, it was like 15 kilobytes per second. We'd get 5 frames per second or something off the rate of this. The standard core libraries, you're talking about 60 kilobytes per second, which is still no good. With this, I've actually tested it at a full 1.1, 1.2 megabytes per second throughput. So, like, I've got the 24 by 24 matrix, and I can push 100 frames, 150 frames a second.
Okay.
Again, depending on the animation, but
Are
Yeah.
you going to allow your users to download code to this thing or anything?
Yes, there is no bootloader on it for a couple of reasons. One, because I'm using the Teensy core, the only bootloader, without me doing a bunch of other weird bootloader things, that would work with it would be the Teensy bootloader.
Right.
But that's not open source. So we kind of wanted to avoid that. I actually did try putting other bootloaders on there and messing around with it, but the difference between the way that the official Arduino bootloaders handle the automatic reboot and
Yeah.
reflash
Yeah.
is so different than the way that the Teensy handles it. At the time I decided it wasn't really necessary. There is an ICSP header on there. You can program it with that. If someone wanted to, say, for example, use this and just run animations directly off the chip, not using the Python library, they could go back to the old Arduino libraries, because at that point the USB serial speed doesn't matter.
Yes.
And then they could use bootloader. It works fine. I have tried that. But the other reason I left the bootloader off is, as you noticed, when I change the strip type, it automatically reboots itself. Well, if you leave the standard bootloader on there, there's about an 8-second delay. And that was just unacceptable for what I wanted to do. I wanted this just, you change it, it goes, oh, it's a different number of pixels, different strip type, cool, reboot, back up. It's less than 3 seconds. So.
And now a word from our sponsor, Maniacal Labs.